Hello, I'm going to be discussing displacement time graphs in this video. In my previous videos, I've already discussed what displacement is compared to distance, speed, velocity, scalar and vector quantities, and I just looked at vector analysis in my previous video. In these videos, I'll be looking at displacement time graphs, and the following ones that are coming out are going to be looking at velocity time graphs and acceleration time graphs. So let's have a look here at displacement time graphs. If we're trying to find distance traveled or displacement of an object at a particular time, we just read directly from the graph. Okay, so it's pretty straightforward. On the horizontal axis, you'll see there's time. You're just reading directly from that particular point that the question's asking. Now, to calculate speed or velocity of an object, we just look at the gradient of the graph. Okay. Now, we're going to answer our exam style question so you get a feel to what would be asked in a specific question in displacement time graph. So have a look at this graph here that you can see on the screen now. And there is 5 separate questions, and they're typical exam style questions. Now, how far did the car travel in the first 10 seconds? Calculate the average speed of the car. Calculate the average velocity of the car. Determine its displacement after 16 seconds. And determine its velocity of the car at the time of 8 seconds. So let's have a look here. When we're reading on how far did the car travel in the first 10 seconds, then we're looking at the distance traveled. So you can see here that at 10 seconds, its displacement is 0, and it began at 15. So how far did the car travel is 15 meters, okay? Now let's have a look at average speed. Now average speed is basically distance over time, and if you haven't seen or you're unclear on how to get that answer, I've done a video on that on the previous videos. Now, to find average speed is just distance over time, and you do 30 meters, which is the total distance traveled, divided by 20 seconds, and it's 1.5 meters per second. Now, if you're wondering where did 30 meters come from, it's 15 meters on the north side and 15 meters on the south side. So the total distance traveled is 30 meters. Now, it's scalar, so you don't need a direction. Now, C, calculate the average velocity of the car. Now, because it's 15 meters north and 15 meters south, its displacement is 30 meters towards the south. Okay, so if we're looking at the time, it's the same time as what we just answered with average speed. So you should get the same answer of 1.5 meters per second south. All right, D, determine its displacement after 16 seconds. Now, this is where topical debates have happened in class where we have interpretation of the answer. Now, I'm saying at 16 seconds that it's at 10 meters south. Now, again, it's interpretation on where you draw the line from 16 seconds, but I'm going to say that it's 10 meters per second south. All right, the last question here, and we're looking at determine its velocity of the car at the time of 8 seconds. Again, it's all by interpretation. So I'm saying here that it's traveled 12 meters south in this time over 8 seconds, which is given to us. And my final answer is 1.5 meters per second south, because it's a vector quantity. I hope you enjoyed watching these videos. My next videos will be on velocity time graphs and acceleration time graphs. And I hope to finish this set of videos or playlist very shortly.